Hello, and welcome to my channel. I am Rob, and today I'll be going over my submission for the week of RSCA Circuit and Coding Challenge for year of 2022, hosted by CSULB, where I won second place. The goal was to build and program an Arduino microcontroller to complete space-themed tasks in about an hour and 45 minutes. For the hypothetical scenario, the challenge participants were astronauts collecting thermal data on the sun when a meteor threatened to crash into our spaceship. We avoided the collision course, but in avoiding certain doom, we flew too close to the sun, which disabled the ship's control. Luckily, we have a microcontroller, a way to program it, and the appropriate components to build our way out of this mess. The first thing we needed to do was to complete our mission and gather data on the sun. I did this by mapping the analog voltage of a temperature sensor to the minimum and maximum temperatures, which you can see in this part of the code. The min-max sensor values are here, the min-max temperature values are here, and the measured sensor value is here. The measured sensor value is cut in proportion based on the min and max, and that proportion is applied to the temperature. So the output of this would be the temperature in Celsius. For the next part of the code, we needed to detect if another meteor was going to get too close. So for that, we had to build warning lights and a warning alarm, and we'd also get extra points if we made a warning display here on the serial monitor. Here's the temperature sensor. Right now it says the temperature is 24, but the actual temperature that it says on the module is 25, or on the component is 25. It's because it's mathematically mapped and it's not 100% accurate, but it does give some pretty close values. For the distance sensor, I use this ultrasonic. It's blue when it's in medium distance. It turns green in far distance, which is over 50 inches. In our hypothetical situation, we're not using ultrasound. We're using a laser distance sensor, and we are getting our values in hundreds of miles, but it would almost be the same application of the coding and all that. So blue is alright, green is super safe, and an annoying buzzer will go off once it goes under 10 inches. I'm sorry you had to hear that. Bonus points were also awarded if you're able to give a warning message when the buzzer went off. As you can see, the warning sign went from watch out to save yourself, which, if the meteor is that close, I don't know how one would save oneself, but yeah, I wasn't able to get the warning done in time, but I'm not complaining. Finally, we can use this the shadow of another passing meteor as a shield against the sun once it gets dark enough to get the ship's controls working. To propel us a safe distance away from the sun to return to Earth. I did this by using a photoresistor and a voltage divider circuit. I built the light sensor and compared the measured value to a dark analog value that I obtained experimentally by messing with the darkness. I'm going to change this so you don't have to hear. For the last time, I apologize. So, once it gets dark enough, as indicated by our thermal resist or our photoresistor, you can't really tell. I probably should have used another value than red because red doesn't look good on Tinkercad. But as soon as it gets dark, the ignition warning sign goes on and this red LED goes on, indicating or that red LEDs to symbolize our ignition or our engines. And for the warnings, once again for displaying the warning sign, I was able to get another extra credit. But this is my circuit. Extra points were also awarded to everyone who completed the project in one board. If I had time, I would want to change the delays to millis. If you notice, when I changed the value of the photoresistor, it took a while. Or also when I changed the value of the um, ultrasonic, it took a while for the value to register and to change and to make the appropriate changes, because this thing is creating an echo with a delay inside the coding. And I would have wanted to change that to Millie's if statement instead of a delay, in order to get around that hurdle that allows the microcontroller to multitask. It would be able to measure and display multiple things at once and have multiple different states, instead of um, this delay, which causes the whole computer to stop production, or to stop working. But either way, I had a lot of fun during the challenge, and interacting with my other CSULB students. And for what I've seen, everyone else did a great job. Thank you for watching, and I hope you have a great day.